Welcome to the new lecture series of Basic Electronics Engineering. Subject code is ECE 102. The topic of today's video lecture is PN junction diodes. Here, before discussing the PN junction diode, we will discuss the course objectives of Basic Electronics subject. It is basically to enhance knowledge capabilities of students through understanding of electronic devices such as diodes, transistors and FETs. FETs are field effect transistors. The students should also be able to acquire basic knowledge of digital electronics and communication systems. This is the syllabus for Basic Electronics Engineering subject. Here we are having two sections, section A and section B. In section A, diodes, different type of diodes and transistors and amplifiers are discussed, and in section B, the number systems and communication systems are discussed. So we are covering all the topics in this lecture series. So the content of this video lecture is: what is PN junction semiconductor diode, what is depletion layer, what is barrier potential, which materials are used for diodes, what do you mean by forward and reverse bias, silicon and germanium, semiconductor diodes, advantages of PN junction diode and types of diodes. Now we are discussing everything one by one. First of all, what is PN junction diode semiconductor devices? A PN junction diode is a two-terminal or two-electrode semiconductor device which allows electric current in only one direction while block the electric current in opposite or reverse direction. If the diode is forward biased, it allows the electric current to flow. On the other hand, if the diode is reverse biased, it blocks the electric current flow. PN junction semiconductor diode is also called PN junction semiconductor device. This diagram shows the PN junction diode. Here we are having the p-type and n-type material. When p-type and n-type materials are brought together, a diode is formed. Electrons and holes merge across the junction. Then the depletion layer is formed, and then the potential difference, that is called PD, or the voltage, is developed across the layer. So this is how the working. This is the depletion layer, and the negative and the positive is the potential barrier. Now first of all, we will discuss what is depletion region. When the p-type and n-type semiconductors are kept in contact with each other, as shown in this figure, this is p-type material and n-type material. When they are brought together, the junction between them behave differently from either side of the material alone. These electrons and holes are close to each other, as here shown at the junction. According to Coulomb's law, there is a force between the negative electrons and the positive holes. When the PN junction is formed, a few electrons from n-type and diffuse through the junction and combines with the hole in the p side to form negative ions, as shown here in the blue region. These are the negative ions which are formed on the p-type side. Similarly, positive ions are formed on the n-type, as here combines with the holes in the p-type to form negative ions and leave behind the positive ions in the n side. This results in the formation of depletion layer, which act as the barrier and does not allow any further flow of electrons from n region to the p region. When this barrier is formed, there is no flow of electrons or holes from one side to the another side. So this is about the depletion layer, and this is the symbol for a diode. This triangle is P and this bar is N. So this is PN junction diodes symbol. And here we are having holes on the P side, and here we are having the electrons on the N side. When these electrons are moving to this side, they forms a negative ions on the P side, and when these holes moved to this side, they form the positive ions, and these negative and positive ions on the edges of P type and N type are called depletion region. Next, barrier potential. What do you mean by this? The N-type and P-type semiconductor materials are electrically neutral before the free electrons and holes had crossed the junction. However, when the free electrons and holes have crossed the junction, the N-type and P-type semiconductors become charged. Initially, they are at neutral position. When the free electrons from N-type and the holes from the P-type starts moving, they become charged. A barrier is built near the junction which prevent the further movement of electrons and holes. This is called barrier or the depletion layer, which prevents the further movement of electrons and holes from both the sides. The negative charge formed at the P side of the PN junction is called negative barrier voltage. This negative is called negative barrier, and while the positive charge formed at N side of the PN junction is called positive barrier voltage, and this is called positive barrier voltage. These are negative ions and these are positive ions, and this is called negative barrier and this is called positive barrier. Negative barrier is on P side and positive barrier is on N side. So the total charge formed at the PN junction is called barrier voltage. The voltage produced between this negative and positive is called barrier voltage, barrier potential or barrier junction barrier. These are the different names. The size of the barrier voltage at the PN junction depends on the amount of doping, the junction temperature and the type of material used. The width of this barrier voltage depends upon the amount of doping, means if they are heavily doped or they are lightly doped, what is the temperature, junction temperature, and which material is used for P-type or N-type semiconductors. The barrier voltage for silicon diode, if P and N are of silicon, then it is 0.7, and if it is of germanium, then it is 0.3 volts. So for silicon and germanium, the voltage barrier potential is different. This diagram shows how the forward biasing takes place in the PN junction type and how the depletion layer is formed. This is my P side and this is N side, and this is forward biasing. Forward biasing means when the P type is connecting to the positive of the battery and cathode, N is connecting to the negative side. But in the reverse biasing, this P is connecting to the negative and this N is connecting to positive. This is reverse biasing diagram and this is forward biasing, and this shows the movement of electrons and holes in the P and N type material. When it is forward biased, the depletion layer is of less width. When it is reverse biased, the depletion layer is wider, as shown here. This is wider. The depletion layer in the reverse bias is wider. In N-type semiconductor, free electrons are majority charge carriers, whereas in P-type semiconductor, holes are majority charge carriers. When the N-type semiconductor is joined with the P-type semiconductor, a PN junction is formed. The PN junction, which is formed when the P-type and N-type semiconductors are joined, is called PN junction diode. So this is a basic definition of PN junction diode. Now, what materials are used for diodes? The PN junction diode is made from the semiconductor materials such as silicon, germanium and gallium arsenide. For designing the diodes, silicon is more preferred over germanium. The PN junction diode made from silicon semiconductors work at high temperature when compared with PN junction diode made from germanium semiconductor. Means the silicon diode can work at high temperatures as compared to germanium semiconductors. Now, biasing of PN junction diode semiconductor diodes. What do you mean by the biasing? When we are connecting a battery to the P and N junction, that is called biasing. The process of applying the external voltage to a PN junction semiconductor is called biasing. When we are applying some external voltage source, the external voltage to the PN junction diode is applied in any of the two methods, the forward biasing and the reverse biasing. If the PN junction diode is forward biased, it allows the electric current to flow. Under forward biased condition, the P-type semiconductor is connected to the positive terminal of the battery, whereas N-type semiconductor is connecting to the negative terminal of the battery. If I am making the diagram for the forward biasing, it can be, if this is my diode, then it is my this is called forward biasing. This is my P and this is my N. P is connecting to the positive of the battery and N is connecting to the negative of the battery. So, this is about the forward biasing. This diagram shows the forward bias and the reverse bias. Now look into this diagram carefully. We are having P-type and N-type semiconductors and they are connecting together to make a PN junction diode, and this is the narrow depletion region because of forward biasing. These are the free electrons and the holes. Now for forward biasing, the positive is positive of the battery, this is the positive of the battery is connecting to the P-type, this is connecting to the P-type, and negative of the battery is connecting to N-type. So this is the forward biasing. In the forward biasing, the current is flowing, and because of the flow of the electrons, the depletion layer width is narrow. So next is reverse biasing. In the case of reverse biasing, P is connecting to the negative of the battery and N is connecting to the positive of the battery, and in this case no current is flowing and the width of depletion layer is wider. The depletion layer is more wider as compared to the narrow depletion layer. Because of narrow depletion layer in the forward biasing, the current is flowing, and because of wider depletion layer, no current is flowing in the reverse biasing. So next is silicon and germanium semiconductor diodes. As I have told you, these materials are used for semiconductor diode. Now we are reading some points about these. For designing the diode, silicon is more preferred over germanium. The PN junction diode made from silicon diode works at high temperature than germanium silicon diode. Forward bias voltage for silicon semiconductor diode is approximately 0.7 volt. It is very important point to note that the silicon semiconductor voltage is 0.7 volt and germanium semiconductor diode voltage is 0.3 volts. Silicon semiconductor diode do not allow the electric current flow if voltage applied on the silicon diode is less than 0.7 volts. Means the external battery which we are applying for the forward biasing, it should be greater than 0.7 volt. Silicon semiconductor diode starts allowing the current if the voltage applied on the diode reaches 0.7 volt. Then germanium semiconductor diode do not allow the electric current flow if the voltage applied on the germanium diode is less than 0.3 volt. Germanium diode is also working at 0.3 volts. Germanium diode start allowing the current flow if the voltage applied on the germanium diode reaches 0.3 volts. Means the starting voltage for silicon is 0.7 volt and for the germanium is 0.3 volts. The cost of silicon semiconductor is low as compared to germanium semiconductor. So from these points we can conclude that the silicon is more preferable over germanium. Because what are the reasons? The first reason, it works at high temperature, it needs approximately 7 volts current, and because of its low cost as compared to germanium. Then advantages of PN junction diode. PN junction diode can be used to convert alternating current to direct current. Alternating current, this is my alternating current and this is my direct current. What do you mean by this? PN junction diode can convert AC current into DC current. Why? Because when we are having the two biasings, forward biasing and reverse biasing. Forward biasing means the current is flowing, and reverse biasing, the current is not flowing. Now when this is forward bias, the current is flowing, no current is flowing in the reverse bias. Then in the forward bias the current is flowing, and in the reverse bias no current is flowing, and in the forward bias the current is flowing. So we are getting this type of output. This is called half wave rectifier. Means we are getting only the half wave. For the full wave rectifier we are getting this type of output at every cycle. In every cycle we are getting the output, and after that we are applying the filter and it will give approximately this type of output. This is called my DC, practical DC output, in which the ripple factor is less. So this is about the advantage, means it converts the alternating current into the direct current. If the diode is forward biased, it allows the current to flow. On the other hand, if it is reverse biased, it blocks the current to flow. In other words, the PN junction diode becomes on when it is forward biased, whereas PN junction diode becomes off when it is reverse biased. That is, it can be act as a switch. What is switch? Switch is either we are having the two conditions, on and off. On means the current is flowing and off means no current is flowing. When the diode is forward biased, it is working in the on condition. When the diode is reverse biased, it works as a off condition, in the no current is flowing. So a diode can be act as a switch. Thus PN junction diode is used as electronic switch in digital logic circuits. So this is how the PN junction diode is used as a switch. So next is different type of diodes. We are having Zener diode, avalanche diode, photodiode, light emitting diode, laser diode, tunnel diode, Schottky diode, then varactor diode, and PN junction diode. Last one is our basic diode, which we are discussing. So these are the symbols for different diodes. This is my basic PN junction diode. This is P and this is N. Zener diode, its symbol, this is for the Zener diode, and this is for the tunnel diode, and this is Schottky diode, and varactor diode. This is my varactor diode, and then this is light emitting diode. Light emitting diode, the arrow is outwards, means light is emitted. Photodiode means light is falling on the diode. When light is falling, the diode is working. And these are SCR, strike, and dike. So these three we will discuss later on. These are the diodes which I named here: Zener diode, avalanche diode, photodiode, light emitting diode, laser diode, tunnel diode, Schottky diode, varactor diode, and PN junction diode. So this is all about the basics of PN junction diode. So hope you like this lecture. Thank you very much.